Alright, today we're going to do a factoring review. These are the four basic types of problems that you'll see. You have two terms, three terms, and four terms. And basically, depending on what you have, is how you're going to approach it. With all factoring problems, you always want to look for a GCF first, a greatest common factor that can be pulled out. So we have 6x squared minus 8x, and we look for anything that we can divide out of them. So between the 6 and the 8, a 2 can come out. Since they both have an x, we can also pull an x out. So 2x is the most that we're going to be able to pull out. We can't pull out 2x's because this one only has 1. This one has 2, but this has 1. So now what we need to do is figure out what we have left. Now what we're looking for is 2x times what equals 6x squared. So 2 times 3 would get us to 6. We need 2x's, and since we only have 1, we're going to add 1 more there. Then we're looking for 2 times what to get us to negative 8, and that's going to be a minus 4. And we need 1x. We've already got one, so we don't need any more x, so this is the answer. And if you notice, this is basically like a distributing problem that we're doing in reverse. If we were to take this and distribute 2x to the 3x and 2x to the minus 4, we would end up with 6x squared minus 8. So just think of it as reversing multiplication. Now, once we get to three terms, there's two different types of problems that we have. One is when there's nothing in front of the x squared, when it's just a 1, and the other is when there's a number other than 1. There's two methods. The method for the second problem that we're going to do down here will work for both. But this method that we're going to use for the first one only works on this. So if you only learn one method, learn the second one. But this first method is a whole lot shorter, and it'll work for all the problems that don't have anything in front. What you do is you start off by finding the multiples of 60, because what you need is two numbers that will multiply together to give you 60, and add or subtract in some way to get 16. So we've got 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and 6 and 10. Now out of these, 1 and 60 will not add or subtract to get negative 16, neither will 2 and 30, 3 and 20, 4 and 15 will give you 11 or 19, which is not 16. This will give you 17, doesn't work. The 6 and the 10 will. The way the 6 and the 10 work to get a negative 16 is a minus 6 minus 10 is going to equal to our negative 16. The last thing to check is, does a negative times a negative equal a positive? And since it does, we have our answer. So we have x minus 6 and x minus 10. The same way you wrote it up here trying to get your middle term is the same way that you're going to put it in. If one of these would have been positive, we would have put it in as a positive. It doesn't matter whether you put x minus 6 first or x minus 10 first. It just matters that they're both there with the correct sign. Now when we get down to number 3, it's another trinomial. We again look for something that can come out. There's nothing that comes out. There's no number that divides into 6, 11, and 4, and they don't all have x's. So in this case, what we need to do is not find the multiples of 4. We need to multiply the 6 times the 4, which is going to give us 24. We now find the multiples of this. So we've got 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Now what we're trying to do is figure out which one of these will get us to negative 11, similar to the last problem. 1 and 24 won't, 2 and 12 will give us 9 or 14, 3 and 8 will, and 4 and 6 won't. Always make sure you check all of them, because sometimes it seems like there's 2 that work, but only 1 actually works. Now, the 3 and the 8 to get to the negative 11, we have a minus 3 minus 8. Still gets you the negative 11. But this time, we don't have our answer already. What we're going to do is we're going to rewrite the negative 11x into these two terms. We're going to basically uncombine like terms in the middle. So we've got 6x squared minus 3x minus 8x plus 4. So the 11x, the negative 11x became a minus 3x and a minus 8x. What we're then going to do is, since we now have 4 terms, we're going to group this together. So we're going to try to factor out something from the left, factor out something from the right. From the left, there's a 3 in common, and we have an x in common. So what we're going to be left with is 2x minus 1. Over here, since the third term is negative, we're going to want to pull out a negative. So between 8 and 4, we have a negative 4 coming out, and that's going to leave us with 2x minus 1. Now, if you notice, they both have a 2x minus 1 in common, so we're going to factor that out. So both of these became this one since we factored it out from both. And what we're left with for our other set of parentheses is the two remaining things, 3x minus 4. So that becomes your answer for 3 terms. Now you have to use this longer method whenever there's something in front of the x squared that's not a 1. If there's nothing in front, we can use the shorter method. And the reason for the two methods is how much faster this one is. And the majority of trinomial problems look like this, but there's still plenty of them that look like this, so you need to know how to factor them. The last thing that we need to do is 4 terms. Now, if you notice, these 4 terms kind of look like the problem that we had up here. So we had 4 terms up here and we split it in half. We're going to try to do the same thing here. First thing is we're going to check for a GCF since they don't all have x and there's no number that comes out of 1, 5, 3, and 15 that's not a 1. Factor by grouping is our only option. So in this case, we can pull out 2 x's because this is going to be the lowest exponent. So I pull out x squared and I'm left with x minus 5. Over here, 3 and 15, I can pull out a plus 3, and I'm left with x minus 5. And if you notice again, the parentheses are the same thing, so we can factor out an x minus 5. And again, we're left with x squared plus 3. And that becomes our final answer. So this problem here, even though it looks bigger than this one up here, is actually a whole lot shorter, because this problem here starts off basically right here in the problem, so we didn't have to do all the other stuff first. So the 4 terms is actually shorter than only having the trinomial.